I believe so. We're gonna be finishing it today.
This is about this is to give us.
I think it's gonna be maybe his, but I'm not sure. Yeah. Probably his. This your song they're asking? Are you gonna send the PowerPoint?
PowerPoint will be sent at the end when we finish. Yes.
Okay. Okay, so let's get back into it.
It's going to be different from yours.
Press it.
It's the same information. Are you gonna send mine or you're gonna send what is?
He
What
is.
is?
I'll send both. I'll send both.
All right, we'll take it.
They're both the same. All it is
One got color in it.
That's it. That's the only. That's why I was like, it don't really matter. Alright, so rotating anode, okay guys? So we're talking about the target. So remember in stationary anode, the electrons only hit at a single point. So like right here, it's called the focal spot. So this is why we don't like it, because it's gonna overheat. This focal spot, the electrons keep hitting it, so it's gonna overheat, okay guys?
It's the focal spot in the focal path.
For this one, for the stationary, it's called focal spot. For the one that's rotating, it's called focal track because it's moving. See the difference? So on a rotating anode, the focal point becomes a focal track, basically what I said. This spreads out the heat and allows higher exposure factors to be used. So like the example when I went around and I showed how she just held the pin right here and it just stayed, it's overheating in this one spot, it's not good, right? So on this one, when it's rotating and it's moving, the heat is getting distributed around, not just hitting one spot, the focal spot. You see, it's focal track, so it's going all the way around. Mr. Phung, you have anything to add or anything like that?
Anyone remember how fast this rotating anode stays?
3,400 RPM.
Oh, great job.
See, I'm a great teacher. Oh, crap. Okay. You guys good? Wanna go to the next one? Huh? Yes, I always ask because sometimes, you move too quick and you don't get, I'm letting y'all know that it's how the perspective is doing. So I'm gonna ask them, are we good? We can move to the next one. I looked also to see if anybody's writing and she's still writing.
Mr. Donnie who asked as well, so I'm just putting it out there. It's worthy.
Perspective.
You're our favorite.
What?
Keep it moving.
What happened? You gonna keep it moving?
Yeah.
We only got like, what, 10 more slides or 9 more slides?
Once the eye of the back on me.
Can we get
Not on the bed.
Mr. Phung,
Yes.
if she finishes these slides, can we get an early release?
No. She does have an activity for you.
Oh yeah, I do have an activity. I forgot.
Reclaiming this time.
Okay, so this is called the line focal principle.
Pay for the time.
So the focal track is located on the angle surface of the anode. So this is the track right here. This is the anode right here, and then this is the angle, right? See how it's coming at an angle? So electrons are coming in and they're hitting this target right here. So the line focus principle, the large actual focus spot size, the actual area of the electrons affected, so they're coming in. This is how thick it is right here. You see how big this is? It's coming in. And then the effective is when once it hits the target, it becomes smaller, as you see, right? So the angle that is usually utilized is 12 degrees. This is the most common, but there is a range, 7 to 18. You also need to know that range. Question?
So we're gonna get into like not SOHCAHTOA, but I forget what it's called. Like triangle math and shit, and physics with regards
Trigonometry?
to trigonometry. Thank
It's
you.
not.
Thank you.
Yeah, it's not really that much. It's just saying like how the angle affects the actual size of the beam, and then how this is becoming the effective focal spot. So it just depends on the angle, is what it's saying. So once it's smaller, then it becomes small. The effective focal spot becomes smaller. So that's all you have to know, like the difference between that. It's not
Okay.
gonna go into like math on it.
So we're not gonna need to know like actual degrees and relationships between focal sizes and all that.
Technically, yes. but it's more like if it's a larger larger angle, then the effective will become larger. So if this is larger, then this will be larger.
So it's a direct relationship as opposed to indirect.
Mm-hmm. So you have to know stuff like that.
Cool.
We don't get into it. But you do need to know the 12 degrees. That is very important. That's the most important. Yes.
So, taking a look at this image, if you compare the size of the electron stream, right? Look at how thick the electron stream is. And then you compare it to the size of the actual focal spot. Which one is bigger? Or are they the same size?
The stream and
It's
the
bigger. Electron stream is bigger.
Electron stream is bigger.
Say it one more time, Mr. Phung.
So
Sorry.
look at the width. Look at the
The
width
electron
of the
stream.
electron stream.
Electron
I
stream
think
is
the
bigger.
electron stream.
And now look at the area of the actual focal size.
They're both the same.
it's the same.
Oh,
So
one looks thicker.
if the focal
Look
spot
at the
size
lines
is
in it.
actually bigger,
Who?
right?
Oh,
What'd you say?
The focal spot size is bigger than the size of your electron stream.
Oh.
So look at the thickness of this electron stream. Look at the size covered by this actual focal spot, right? So which one's bigger? Actual focal spot or electron
What you got
stream?
going on?
Actual focal spot is bigger than the width of the electron stream. Why is this important? Why is it nice to have a larger actual focal spot size? So if you want, right, I've got some rulers right here. Being prepared.
They're fine, always come.
You can even measure up the size of this electron stream. Right now, 2.5. I can measure out the size of this actual focal spot size, 3 inches. So this angled area is larger than the height of this electron stream. Why is that a nice thing? Why is that a good thing? What happens at the actual focal spot size? Or at the actual focal spot?
Let's get hit right here. What's going on? Heat.
Heat. So, by having an angle, the line focus principle tells us that by having an angle, we increase the area that the electrons have to hit. Which means, what are we doing to the heat?
Increasing the heat.
We're spreading it out. Very good. We're spreading it out so we don't heat that area as quickly, right? It takes longer to heat up that area because we're spreading the heat out. At the same time, we take a look at our effective focal spot size. I'll give you a little preview. Effective focal spot size determines the sharpness of your image, how clear your image looks. So, what you're doing is, imagine the patient's down here, and they're looking straight up at this target. This area they see, this actual focal spot they see, that is their effective focal spot. They don't see the entire face because it's angled, right? It's like, okay, right now you see the whole ruler, right? I angle the ruler, it looks smaller, right? It looks foreshortened, right? It doesn't look as long if I angle it like this. Same thing. So effective focal spot, because it's looking at an angled target, the effective focal spot size is going to be small. The smaller the effective focal spot size, the sharper your image looks. Once again, that is due to the line focus principle. It's how the angle correlates with the size of the focal spot. So if I increase the angle of the anode, instead of 15 degrees, let's say it was 18 degrees, or make it something big like 30 degrees, what would happen to the size of the actual focal spot? Increase. So what does that do to the heat in the tube?
Reduce.
Good, spreads it out, reduces it. What does that do to my sharpness, my effective focal spot size? So
The sharpness will decrease.
Alright, so bigger angle. So bigger angle, right?
So it'll be larger,
So larger effective focal spot size
but it decreases your sharpness.
and lower sharpness. So that is line focus principle. Yes, Reagan.
This might be a dumb question.
No,
No
no,
dumb
dumb
questions.
question.
Where is this going on at? Like, where the picture that you have there?
Oh, this is a sideways view of your rotating anode.
Oh.
So cathode's over here. Electrons are getting shot across the electron stream. You see, they're getting shot across, and they're hitting the anode. Like that, right?
Yeah.
So you said bigger the angle decreases the sharpness?
Correct. So in general, if the actual focal spot size gets bigger, the effective focal spot size also gets bigger. So that means heat and sharpness are connected. Increasing actual focal spot size lets you spread out heat better, but at the cost of image sharpness.
And when you have a smaller angle, there's more heat hitting in that area. Right? So that's why we don't really. I mean, you want a sharp picture, but the reason why we don't like this smaller focal spot is because of the heat. Okay, we're still talking about it.
So,
Oh,
You got a question?
so, more heat,
More heat with less angle,
less angle,
and then
better.
small
I
effective.
mean, better
Image.
picture, image, right?
Mhm.
But
Hold on, wait, say that one more
I
time.
said more heat,
More heat,
More heat.
smaller angle,
smaller angle,
better image.
better image.
Yes.
Very
But
good.
if you got more heat,
Mhm.
bigger angle,
The sharpness is
the
not as
sharpness
good.
gets worse.
Yes.
I mean, it's not better, it
It's not as
decreases.
good.
Yeah, okay, got
So
it.
yeah, spread out the heat with a bigger angle, but sharpness is worse.
So you have better heat, but you have poor sharpness, it's not.
Correct. So you have to balance out the heat production and the quality of your image.
So I just wrote large angle equals larger focal spot
Mm-hmm.
equals less sharpness.
Correct.
Cause then I can just think of it like flipped the
Mhm.
other way.
Okay, so same thing over here. So this is showing the difference. So we have a larger angle, right? Look at our effective focal spot size. Is it large or is it small compared to this side? It's larger, right? Because you have a large angle. You come over here, you have a small angle. Is it small or is it as large as this one? Which one's smaller? Small, right? So, question. Which one would produce a sharper image?
The smaller.
Smaller.
Yes. Okay, and then so, which one is better for heat that you don't want?
Large one.
The smaller one is more heat, the larger one is less heat, but you still don't get a sharp image.
The smaller one is more heat.
No, no,
Yeah,
no,
smaller
she
one
said
is more
opposite by mistake.
Yeah, she said, okay, I was making sure. I was
She
making
doesn't-
sure, like, I want to correct, so the smaller
Smaller
one,
one is more heat,
It's
but
less
no
heat.
sharpness.
Yes.
The larger one is less heat, but bad
No,
sharpness.
sir.
Yes.
It says smaller heat is more heat. How can it be? Smaller
Are
heat
you
is less
okay?
heat.
Smaller
Me, it's
angle.
not okay, they not okay, I got it.
Smaller
so I was
angle
just making sure.
It's less heat.
is more heat. Small angle concentrates the heat in a small
I
area.
got it.
Big angle spreads
I
the
was
heat
actually mad
over
at
a
me.
big area.
Have
Yeah.
you seen a magnifying glass before? Have you ever
Okay.
put a light through
So
a
smaller
magnifying
effective
glass?
focal spot size leads to sharper images, like we said. So smaller angles, better electron beam. Small angles have downsides. X-ray beam might not be able to fully expose a 14 by 17 inch cassette at a 40 inch SID, which causes the anode-hill effect too.
Not positive. but-
Not causes, sorry. There's also the anode-hill effect, and the anode angle cannot be changed by at the console. So we can't. We have no control over this, basically.
That's the machine, like how it's
It's just
built.
how it's built. Yeah.
So if you do want to change the size of your focal spot, and you know that you can't change the angle size because you get what you get, how else could you possibly change the size of your focal spot?
Turn it on.
Based on something we discussed
Really.
last week.
You have two of them.
Yes, two of them.
The control factor.
No, it's on the cathode
What,
side.
what was the question?
So,
We can't angle.
so if you want to change the size of your focal spot, but you can't change the angle is built into the tube. What can you do instead to change the size of the
Increase the
focal spot?
heat or decrease the.
Nothing. Nope.
There's two.
Angle the
The
other
focus
And
side.
it's on
No.
the cathode side.
But it has to do something with the focus.
Filaments, yes. So what is that called when there's two?
Dual.
Oh, dual focus.
Yes.
And what was special about the two filaments in dual focus?
One was thicker, one was
Yeah,
Yes, so you can change the size of the
Of the
electron
sorry,
beam.
we're
Yep,
like
go
that.
ahead.
The actual focus spot.
Correct. Right, so, right, your dual focus cup, one small filament, one large filament. Right, so the bigger the filament, the thicker the electron stream, right? The thinner the filament, or the shorter the filament, the smaller the electron beam, right? Depending on the size of this electron beam, that determines the size of your actual focal spot. So, which one will produce more concentrated heat? A small filament or a large filament?
Small.
Small, right? Small filament gives you small focal spot size, and that means more concentrated heat, right? You've got a lot of heat in a small area. Which one will give you better sharpness? Small filament, right? Because yes, you get more heat, but you also get a better image. So, if you were doing something like an abdomen, right? Really thick body part, you're gonna need a lot of x-rays. You're gonna need to really blast that tube. You're gonna be producing a lot of heat, right? Which filament do you think you would want?
Small.
The large.
You would want the large. You want to be able to spread out that heat so you don't burn your tube out all at one time. Yes, Reagan.
So how do you have control of that?
Great question. So on the control panel, there is actually a button that you can use to select a small focal spot or a large focal spot. It looks like, so depending on the hardware, I think for Philips, it looks like a square. There's like a big square and a small square.
I've never seen them change it, ever.
Yeah, techs just hope that whatever was programmed works and they just press the button. But yes, you do have the option of manually adjusting it. Actually, later on I'll pull up, if you're still curious, I'll pull up my old PowerPoint from chapter 1 and I can point out exactly where on the control panel it is. Okay.
Okay, so Mr. Phung, do you have these printed?
I do, so let's finish this and then we'll do that activity.
Okay, so the anode hill effect. So there are fewer X-rays on
Or-
the anode.
Actually, do you want to do the activity first?
I feel like
feel like it would make more
I think
sense.
it would be like make more sense
Okay.
to do the
In that case,
how many
so we have 14, so we can do groups of 7. Or they can try and do their own individuals, but I don't have enough numbers for that.
what about 2, 3?
Yeah, we can do 2.
Okay, and with partners, just 2.
All right, we have 14 people, so let's form 7 groups of 2. Right, so groups of 2, please.
I'm completely